Welcome back. This is the second lesson recording for IM2, January 7th, 2021. Now that we've talked about multiplying binomials using area model, let's see if you can go backwards. If you have the rectangle, the area model filled, can you figure out what the factors are? Can you figure out what the length will be and what the width will be to get this area model? Well, we're looking for the length and the width here. So to do that, you start by finding the GCF for a row or a column. It does not matter whether you start with a row or whether you start with a column. For the sake, I am just going to start with the column this time. Now you're looking at 6x squared and 2x. Looking at this column, what is the GCF that I can take out? 6 and 2, they're both even, so that means I can take out 2. X squared and x, there's two x's being multiplied and one x being multiplied, so I can take out one of the x's, so I can put 2x right there. Then I can figure out what this question mark value should be. Okay, it's because 2x times what is 6x squared, that has to be 3x, because 2x times 3x is 6x squared. Now we can figure out what this question mark is, because I know that this number 3x times what is 15x. 3x times what is 15x? That has to be 5, right? Okay, so we figured out what the top factor or the length factor is. Now the only thing we're missing is this. Okay, so then for this number, we're multiplying. To get this number, you're multiplying this 2x times this question mark number, right? What does that number have to be? 2x times what is 2x? This has to be positive 1. Okay, it's always good to check the very last value to make sure that this works out 5 times 1, because sometimes you are going to get plus and minus mixed up. Okay, so and this way you know that all the boxes do check out. 5 times 1 is 5, so it checks out. So this tells us that the factor of 6x squared plus 17x is the sum of 15x plus 2x. So 6x squared plus 17x plus 5, the R, 2x plus 5, that's the top length, and 3x plus 1, that's the width. Okay, so this is the area model factoring backwards. So tell me in private chat, okay? I want you to try to do this yourself now. I have actually broken up the negative 39x as negative 4x and negative 35x, and I'm going to show you in the next slide how that is being broken up. And this quadratics has been broken up into this area model as well. Okay, so now you're looking for the two factors. So to do that, remember what you need to do is you start by doing the column, factoring the column and figuring out what this number is and the rest. Okay, so pause the video and see if you can figure out what are the factors. Assuming that you have done so. Okay, 10x squared and negative 35x. The factor has to be 5x, because 10 and 35, the biggest number that is factorable between 10 and 35 is 5. And then x squared and x is going to be 5x. Now that we have 5x at the top, what is the number 5x times what is 10x squared? It has to be 2x there. And then you can figure out what number I should put here. 2x times what is negative 4x? It's negative 2. Now finally, the last number is 5x times what is negative 35x? It's going to be negative 7. Then you do want to check the last box. Negative 2 times negative 7 is positive 14. So now I have figured out that the two factors are 5x minus 2 and 2x minus 7, as I have here. Similarly, for this problem, you have got the area filled out. Now this time I'm going to go with the row. Okay, I said that you can start with a row or column, it does not matter. If I start with a row, what is the GCF of 12x squared and 16x? Well, I know that 12 and 16, they're both divisible by 4, so I can take 4 out and also an x. So that's 4x here. 4x times what is 12x squared? This has to be 3x. Okay, now that we figured that out, what is this number going to be? 3x times what is negative 9x? It's going to be negative 3. Now we're looking for the very last missing number. So 4x times what is 16x? This has to be plus 4. And then you do want to check the last box. 4 times negative 3 is negative 12, and that checks out. So my factors, two factors are 3x plus 4 and 4x minus 3. Okay, great. Now that you know how to factor backwards, we're going to put it all together. So to factor 6x squared plus 17x plus 5, we've split it up. How did we split it up? It's actually the same method that you've been using in grouping. You start by putting your diamond method, x, and to same as we did before, okay? The top number is going to be multiplying the very first term, the x squared term, by the constant. So it's going, you can do 6x squared times 5 to get 30x squared, or you can just write 6 times 5. But in that case, you, when you are filling the boxes in, you do need to add the x. So whichever one is easier for you, I am good with, but you do need to remember to not just solve it, but when you're filling it in, that you need to enter the x as well. And I'm going to show you that. All right, so looking at this, how do I solve this? I'm looking for a factor, two numbers that multiplies to 30 but add to 17. And looking at the factors of 30, 1 and 30, 2 and 15, 3 and 10, and 5 and 6. This is my complete list of factors of 30. And I know that I've exhausted the list because 5 and 6, after that, it becomes 6 times 5. You've based 6 times 5 is same as 5 and times 6. So you've exhausted the list. That's the complete list. What is the combination that's going to give you 17 as the sum? That's going to be 2 and 15. So I put down 2 and 15 here. But in this case, since I'm dealing with x squared, I can put 2x and 15x, or you can just put 2 and 15. But when you are filling in the box, you are going to be not just putting the 2 and 15, but you are going to put it as 15x and 2x, because we've split the 17x as 15x and 2x, just the same way that we've been doing it in grouping. And then from here, you're just basically factoring the row or a column, or column or a row, and figuring out that the factors have to be 2x plus 5 and 3x minus 1. So those are the length and the width, and you can put that as your final answer. Okay? All right, so I do want you to just have a quick look at the diagonal patterns. All right, so when we've split the 17x as 15x plus 2x here. Okay, and just this is the same method that we did in grouping symbol, right? When we were using the grouping method, we went through the diamond, we solved the diamond by finding the factors of the top number, and then we split the middle term 17x as 15x plus 2x here. It's basically the same thing here, but whatever you've split, you're putting it into the box. Okay, so you're putting it into the boxes and then you are solving them. Okay, and then you're finally solving by factoring the column or a row and finding the factors. So some of you might find this method a little bit easier to process. The disadvantage of this method obviously is the fact that it is going to be slower because you are having to draw a rectangle, an area model every single time. Okay. All right. So, but I want you to also notice something. Okay. What is the pattern in the diagonal? 6x squared and 5 and 15x and 2x. What are the patterns? These are all the solutions that we've been working on today. Today, or actually last lesson and today. What are the patterns do you notice about the diagonals? Well, it should be the same as the grouping symbol. The diagonals, because that's are always going to end with the same product. Okay, 6x squared times 5 is 30x squared, and 15x times 2x is 30x squared as well. So the answer is the product of the diagonal terms are always going to be equal. Great. So then these are the steps for factoring using area model that you can take down if you like. It's pretty much the same steps as the grouping symbol or grouping method up to here. Okay, so well, you need to draw the area model, I suppose, and then you need to put in the x squared term and the constant term, and then solve the diamond, and then fill the area model, and then find the size of the area model by factoring out the GCF of each row and column, and then writing the results as of factors. So let me go through that right now. Okay, another example, 9x squared minus 30x plus 16. If you have this, the first step is to draw your area model. Second step, solve the diamond. Third step is find size of the area model, and then finally write the factors. So let me just go through that now. So I draw my area model, and to fill this in, I put the very first term, which is 9x squared, on the top left corner, and then plus 16, the very last term constant, on the very bottom corner. This is what's going to be always the case. All right. Then now we need to solve the diamond. How do I get the top number? Top number is multiplying the top, the first term, which is 9x squared times 16, or you can just multiply 9 and 16, up to you. And when I do that, I get 144. And the middle term is negative 30. So this is exactly the same way we fill the diamond in the grouping method, right? So you're repeating the same thing. Now we're figuring out, we need to figure out the two numbers, two numbers that needs to fill in here. Okay, so we're looking for factor of 144, but we want the sum to be negative 30. So it could be 1 and 144. Obviously, the sum is not negative 30, or 2 and 72, not 30, 3 and 46, 48. Okay, 4 and 36. If I add this, we're getting closer. 4 plus 36 is 40. We're getting close to 30, but not quite. 5 is not divisible. 6 times 24. And if I add these two, I get 40. All right. But, oh, I mean, I get 30, but I don't want positive 30. I want negative 30. So I need to change both the symbols as negative 6 and negative 24. And this tells me I need to fill the box as negative 6x and negative 24x. And then from here, you solve. And then find your factors, and those are the factors.